Hello everyone, my name is Leanne Fakir, nurse and diabetes education and management student at Teachers College. Today I'm going to talk about nitric oxide and its role within the body, within the normal body, as well as how a body with diabetes can impair nitric oxide and ultimately change the effects of it within the body. First of all, interesting fact about nitric oxide: 3 pharmacologists were awarded the Nobel Peace Prize in Physiology or Medicine in 1998 for their discoveries concerning nitric oxide as a signaling molecule in the cardiovascular system. So what is it? What is nitric oxide? It's a free radical gas made primarily from L-arginine, which is an amino acid, and from nitric oxide synthases. There's 3 of them. They're abbreviated NOS1, NOS2, and NOS3. They create nitric oxide under different circumstances so that NO, which is the abbreviation for nitric oxide, can do different things in the body. So let's talk about what those different things are. One of the most important things is that NO regulates circulation within the body. It acts as an endogenous vasodilator. So NO3 is found in endothelial cells as well as hemoglobin. After the pressure of blood flow in vessels signals a reaction, endothelial cells will try to fix it, or hemoglobin, and it will create nitric oxide using that enzyme, NOS3, and L-arginine, and that gas will be produced, cross through or diffuse through into the smooth muscle of the vessels, in which it then dilates the vessels. This is actually how nitroglycerin works in patients suffering from angina. When the dilation of the vessels needs to be finished, there's an enzyme called a phosphatase enzyme that actually stops the dilation. And this is, interestingly, how erectile dysfunction medications work. They actually inhibit that phosphatase enzyme from stopping the dilation of the vessels, the blood vessels in the penis. Interesting to know. Another important effect of nitric oxide in the body is the influence on neurotransmission. So another enzyme or isoform, NOS1, is found mostly in the central and peripheral nervous system. And it creates nitric oxide to help with the phosphorylation of ion channels that help the transmission of nerve signals to each other. It also helps peripheral nerves get their messages to the brain. Finally, nitric oxide is also very important in the immune response resulting from an injury such as a wound, infection, or even a tumor. So the enzyme that creates NO in these situations is called NOS2. It used to be called the inducible NOS because it's only creating NO in response to an injury or infectious process. And it creates a lot of NO, about 100 to 1,000 times more than the normal amounts found in the body. Because of this, NO is very interrelated with growth factors involved in wound repair. It helps with cell division, maturation of cells, formation of new blood vessels and lymph ducts. It also helps with fibroblasts to help tissue heal, and cross-linking collagen fibers to strengthen healed tissue. So very important. So what does this all mean to our patients with diabetes? Patients with type 1 and type 2 diabetes often have a decreased ability to produce nitric oxide. And some of the reasons might be reduced kidney function or dysfunction, either from typical aging or from patients with diabetes having kidney dysfunction. They don't eliminate a natural inhibitor of NO called ADMA. So in essence, they're inhibiting their nitric oxide. Also, the isoforms NOS1, 2, and 3 work a lot better in an alkaline environment. They're very pH dependent enzymes. And because a lot of patients with diabetes have a more acidic environment due to glycolysis or ketoacidosis, sometimes that inhibits them from working well. Also, that chemical reaction to make nitric oxide needs oxygen. So if circulation is impaired, they can't make nitrous oxide. And sometimes even when a patient with diabetes is able to make nitric oxide, because their glucose levels are higher and they're glycosylated to hemoglobin, a lot of times that creates a very strong bond for nitric oxide to not be able to be released into the smooth muscle and dilate vessels. So now that we've kind of put together what NO does and how it can be inhibited or not produced well in the patient with diabetes, here's some of the complications that can result from that. Poor circulation. Poor circulation causes poor circulation, and it can be enhanced from the lower levels of nitric oxide. It also helps or causes patients to develop ulcers more easily, and then you don't have the working nitric oxide in the immune response and the wound healing that you would normally. So higher rates of infection can increase, and additionally wound healing can be affected as well. Additionally, nitric oxide really can sort of explain some of the cardiovascular disease processes that we see in patients with diabetes, as well as strokes. So I hope this paints a clearer picture of nitric oxide to you, and I hope that you understand now how the production is affected by patients with diabetes or by diabetes, and how a patient with diabetes can be affected by a lower level of nitric oxide. Thanks. Have a great night.